Let's continue talking about SD-Access device roles. In this case, we're going to talk about the extended nodes. The extended nodes are used when you want to extend your fabric into a different building using a trunk connection. So, for instance, you might want to extend your headquarters fabric into a factory or maybe a warehouse that is nearby. And in order to do so, you will have to connect your use one of your edge nodes and connect through fiber an extended node to this edge node. You might want to, in this case, use a carrier that might provide you a LAN-to-LAN connection from here to here. And in this case, you will be extending your fabric to another building. This is a way of doing it. And there are other ways to extend your fabric using layer 3 solutions, but this will be a layer 2 solution in order to extend your fabric. So you have to follow some rules in order for this to work. You will be daisy chaining your extended node to your edge node, and you have only one hop allowed for this daisy chaining. So that means that if you wanted to connect an extended node to your extended node, that will not be allowed, and you will have to run here .1q. So you have a trunk here in order for this to work. And just a note here before going any further: the addressing that corresponds to these extended nodes are not placed in the global routing table as other devices. Remember that when we talked about the underlay, the loopback IP address that belongs to the edge nodes and intermediate nodes and other nodes are placed in the global routing table. But the IP address that correspond to the extended nodes are placed in another routing domain that is known as the infra virtual network. The other devices that are IP addresses that are placed in the infra virtual network are the access points. So remember that the extended nodes and the access points in fabric mode IP addressing is placed into this virtual network. So to summarize, your extended nodes are connected to your edge nodes using a layer 2 connection, and you have to run here a trunk with .1q, and you only have one hop for your daisy chaining allowed. There are two types of extended nodes: classic extended nodes and policy extended nodes. And the reason you are using extended nodes is because you want to enjoy the benefits of having a fabric network. So you want to enjoy here for your end devices that you're going to connect to your extended node, the network access control benefits, the security benefits that come from virtual networks, security group tags, and so on. So you want to benefit from that, and this is what you want to do, all of this. So let's examine what are these classic extended nodes and policy extended nodes. The classic extended node is able to become a AAA authenticator, and it supports the dynamic VLAN. So that means that when you connect a device to your extended node, that extended node can authenticate this device with the help of ICE, the ICE server. That, remember that ICE is a AAA server for your fabric. So the extended node, when it is a classic extended node, can do that, but it does not support a scalable group tag mapping. So it cannot assign a scalable group tag here. It cannot do that. So when the traffic reaches the edge node, then that traffic can be assigned an scalable group tag. That will be the disadvantage of using classic extended nodes. And this has an issue because if you have two devices that exist in the VLAN, in the same VLAN, for instance, VLAN 20. These two devices exist in the VLAN 20. They can communicate with each other without any security enforced into this communication. So, because we are not assigning a scalable group tags at this point, the same VLAN east-to-west traffic will not benefit from a scalable group access control list. So, east-to-west traffic in the same VLAN will become an issue. It can become non-secure traffic. However, if these devices existed in different VLANs, for instance, VLAN 20 and VLAN 30, then the traffic will have to go through a default gateway, so you'll have to travel into the edge nodes, and then when it arrives to the edge node, it will get assigned a scalable group tag, and then that traffic could be secured. So the issue with classic extended nodes happen only with same VLAN east-to-west traffic. Compare that with policy-based extended nodes. These nodes support scalable group tags, and that means when a device gets connected to the network, and this device will authenticate it using network access control, but will also assign a scalable group tag. And remember that given we don't have a VXLAN here, we only have .1q to communicate the H node with the extended node. The only way we have to communicate the scalable group tag is using inline tagging. So we are going to use inline tagging in this connection because we are not using VXLAN. Remember that within the fabric, we're using VXLAN, and when the transporting traffic within the fabric, we are using the VXLAN headers in order to communicate the scalable group tag, because we're using a field within the VXLAN header to communicate this value. But between the H node and the extended nodes, we are not using VXLAN. We are only using a .1q connection. So we need another mean to transport this scalable group tag information, and that is inline tagging. So you'll have to review how TrustSec, Cisco TrustSec works in order to understand what is this inline tagging. So also, the SD-Access solution will internally use this 8000 scalable group tag when you're using extended nodes. So make sure to not use this number when defining your scalable group tags within your fabric, because it is used internally to manage these policy extended nodes. The hardware that you can use for the extended nodes is hardware that is capable to run in extreme conditions, because you want to install this in a factory or in a warehouse, for instance. So this is the hardware that will support being a classic extended node, and this is the hardware that can support being a policy-based extended node. That's it.